Okay, so I think my voice is clearly audible to every one of you, and the screen is visible, and the tick mark is visible too. Okay, so in the way of learning sequential circuits, okay, in the way of learning sequential circuits, till now we covered a lot of things. First, I'm gonna summarize all of these topics, so I need you all guys to hear this out. First, in sequential circuit, we describe first what is combinational circuit and how we build a sequential circuit using a combinational circuit. What are the main differences between them? Okay, and what extra building block if we add in combinational circuit? After that, we will get sequential circuit. After that, in sequential circuit, we started learning latch, right? So in latch, we learned how we will build latch using the universal gates NAND as well as NOR, and we also perform the operation and write the truth table for the latch. Okay, this is the main understanding point of view of sequential circuit. As I told you all guys, if you didn't understand the latch concepts and the truth table clearly, you will be in more trouble in the next sessions of sequential circuit as well as register and counters. This is the main basic point and basic understanding and concept of sequential circuit. After that, we learned what is clock, what is enable, what are the main differences between the enable and the clock, as well as we learned triggering method. Okay, what are different kind of triggerings, and there are some examples are there how we will use the triggered method in latches and flip-flops. Okay, and after that we go towards flip-flop, and we learned how we build flip-flop through latch and what are the basic fundamental differences between a flip-flop and a latch. After that, we performed some operations and some examples we already solved out. Also, after that, we learned SR flip-flop and SR flip-flops to tables in terms of next state and present state. Everything we learned till now, and also we covered the truth table, and using truth table how we will build the characteristics table. And after learning how we will build the characteristics table, we also learned how we will build the excitation table using the characteristics tables. And also we learned D flip-flop and the same things as SR flip-flop. We learned every details till now. So I recorded this lecture for you since you guys have your exam in nearest, so you didn't have enough time, and also MPS period is recently for special problems test series is ongoing. So this is why today the lecture will be completely on JK flip-flop. Okay. So today we will learn what is JK flip-flop, why we need this JK flip-flop other than we already had SR flip-flop, and also the data to storing purpose. We know how we designed a D flip-flop, how we will use it. Such kind of things we already familiar with, and today I am going to teach you, and we will going to learn what is JK flip-flop, why we will need JK flip-flop. Still we have SR flip-flop. Okay. So this is a lecture. I think if you I'm recording it. If you learn this through recorded version, it will be clear to you. And after today's session, I will take a one long session for you guys, learning about some applications about JK flip flop. Some many things we will discuss it in future, and also the flip flop to flip flop conversion. I think in your calculated syllabus it will. This was included as you guys informed me, but I will learn it because if there are some tricky questions are there, then the flip-flop to flip-flop conversions will be there in your exam. Okay, so we'll learn it. So I think I will take one more long session, and this will cover the topics. and this lecture, since this is a recorded one and no interaction with students, and I will record it is in English communication for better understanding to everyone all over the India, and I will upload this lecture on YouTube, freely available to everyone. And if you guys, any of you want the paper of today's session, simply DM me, I will send it. Okay, so let's learn GK flip-flop. First of all, I do apologize for my handwriting, as I always did. Okay. Yes. So to learn GK flip-flop, we will first draw the truth table of SR flip-flop in terms of present state and next state, and also the how we build a SR flip-flop we draw here using NAND gate. Okay. So let's draw the flip-flop first. Take the two inputs is and another one is R. This is S and R. What are their full forms and why we write is S and R, set, reset. This kind of concept I cleared you with you all in your first introduction session of sequential circuit. Okay, so let's trigger it off. Okay. After that, what will we do? We'll simply add the latch. Here these are latch circuit. We'll take one input as output as Q and output as what? Q complement. So this is the, and after that we do a bit the outputs. Okay. So this is SR, the inputs, and we integrate it with clock, and after that we'll get the output Q and Q complement. Okay, this is the basic circuit of SR flip-flop, as you guys already familiar with that one. Now we will write it down a truth table for that flip-flop in terms of next state, Qn plus 1, and present state we consider here. If Qn plus 1 is the next state, then what will be the present state? It will be surely Qn. So this is this R, where we write this as output Qn plus 1. Okay. So what we learned in previous session, if we make the clock is in low state, then we also get the memory. Okay, so memory means the next state will keep the output of the previous state. Okay, so previous state means Qn plus 1, previous means Qn, and it will not depends upon the inputs of S and R. Okay, these are the things we discussed in previous session. If you have any doubts, I request you guys to follow the previous sessions, recorded versions or paperwork. It will be clear to you. After that, we make the clock high and then 0 0. This is also a memory condition. Okay, this is a different condition. 0 1 1 0 1 1. And in both cases we keep the clock in high. So 0 1 means what? 0 1 0 means 1, and 1 1 the not used or invalid condition that we won't be able to overcome with SR flip-flop. So in the okay, so this is the circuit diagram of a SR flip-flop, and this is the truth table in terms of next state and previous state or present state, whatever you may prefer for your convenience. Okay, so this is the memory sort of nomenclature you write for your convenience. Yeah, this is a not used state or anything you may use for understanding purpose. So now what will we see that I recently mentioned, when we make the clock high and take the both inputs S and R in high, then we won't be able to get a satisfactory result in output. Okay, this is the thing I discussed it in details why we won't be able to get a satisfactory output state or output in case when we make the both inputs of a flip-flop SRN or a latch SRN latch. So this is the quite contradictory condition that we didn't uh, overcome with SR flip-flop as well as T. T flip-flop is something that condition on available. This is to overcome the condition which is single. That's kind of stuff I already discussed in previous session that I'm not gonna share it up now. Okay. So this is a not used condition simply. So now using JK flip-flop, why we will bring the JK flip-flop into flip-flop family? The main reason is to overcome this not used condition. Okay. So now we will learn how we will build a JK flip-flop using SR flip-flop. So the process is quite simple and easy. So what will we do? We just make the 2-input NAND, these ones, into a 3-input NAND. So what will be the other inputs? See, the Q is feedback into the R R in the input of this NAND gate. So Q will be feedback into this R clock and this input. So another input of this lower NAND gate is Q. Yeah. And the vice versa, Q complement will be feedback into what? This NAND gate. Yeah. So this is the process. Which this circuit is quite a bit of hazy, and I think it is quite legible to all of you. This is the circuit of a JK flip-flop, and when we use the 3-input NAND or implement the final output into the input of the previous one, then this SR and this changes to J and K. Okay, so this is the circuit diagram or design of a JK flip-flop. Now we will run what will be the output of the JK flip-flop, how we will overcome this on condition. Okay, and what is the truth table of JK flip-flop, and also the excitation table. To learn excitation table we must have the characteristics table. What will be the characteristics table as well as the excitation table of the JK flip-flop. Okay, so let's draw the circuit diagram of JK flip-flop clearly here a little bit, so we will be able to write down the truth table for that purpose. Okay, so it will be to bigger logic gates because these are 3 inputs on. Yeah, this is the input J. Here lock is there. Okay, so this is the another input K. Let's put these things here first. So this is Q and this is Q complement, and this is the sorry for the interruption. There is some antivirus issue. Okay, so we designed the JK flip-flop properly here. Now we paint down using the circuit what will be the truth table of a JK flip-flop. Same things is entered in a place of in terms of A scenario, here it will be J and K, and also the output will be Qn plus 1. So now the question arises, what will be the truth table of a JK flip-flop? Let's minimize this a little bit. Yeah. See, in case of when we keep the clock 0, so if any of the inputs are 0, okay, then it will be what? It will be what? It will be 0 in multiplied by anything is 0. So after 0 complement, this is 1, and this is same thing, this is 1. So 1 1, this is 1 in case of latch is a memory condition. So here simply it will be independent of the inputs, and because always take the higher output and memory condition. So this is simply Qn plus 1 is Qn, as you already knew, sorry. And also when we make the clock high, also the both of the inputs are 0. This combination of first bit, both of the inputs are 0, and 0 0 is also the memory. Okay. And when we make 0 1, we will take the 0 1, then 0 1 it will be the, what is it, 0 1, J is 0, K is 1, then it will same as it performed in case of SR flip-flop. Okay, you may see a little bit and you will identify that it will be same as SR flip-flop, because nothing is changed. Okay, same operation as SR flip-flop. So 0 1 is 0 and 1 0 is 1. Now the question arises, what will be the 1 1 state? This is the thing, this is the main point when we needed to design the JK flip-flop, because the 1 1 state, when both of the inputs are high, SR flip-flop would didn't able to verify or overcome or give the satisfactory output for that purpose. When we make both of the input high, then we will not get, still now we didn't get any satisfactory output stage or anything else. Okay, so how will we overcome that through JK flip-flop? Now we will see. So when both of the inputs are high, let's minimize it a little bit and understand it quite properly. Okay, so here uh, I think I want to tell you one thing. If 0 1 and 0 1 0 is or 1, why we recently, why I wrote it recently here, I think these things are quite clear to you. If it didn't clear to you, you may see the first session of SR latch. Okay, clock 0 is simply okay with that. I think you guys already okay with that. When clock is 1, J is 1, K is 0. That means what? That means what will be the value of Q and Q complement? Q is simply what? When J is 1, K is 0. If you put the value Q, J 1 and K is 0, then what we will get? When J is 1, K will 0, Q will be 1 and Q complement is 0. And when J is 0 and K is 1, what we will get? We will get Q is what? Q is simply 0 and Q complement is 1. So this is why we wrote 0 and 1 was same as SR flip-flop, no difference here. Okay, the only difference of truth table in JK flip-flop is only that part, that row will change. And what will be the change, I will gonna tell you. So I request you guys, please hear this point quite seriously. Okay, this is the main point, main fundamental reason of building or inventing the JK flip-flop. Still we had SR flip-flop as well as D flip-flop. Okay, so let's write these things with a different color. Yes, this is quite different other than white. So now clock is high, that's not a problem for us. Okay, and we take J is 1, K is 1. Okay, now the question arises, what will be the value of Q and Q complement? Okay, equal to what? So for understanding purpose, let's assume what we will assume? Q is 0. So if we assume Q is 0, Q complement simply what? 1. So let's put the value of this in there. So if we put J is 1, K is 1, Q is 0, as well as Q complete was. Clock is what? Clock. This is clock. Wait, forgot to trigger it. This is clock. So when clock is high, clock is 1. So this will 1, this will be 1. And J in J, the third input will be Q complement. Here we take what? We took Q complement as 1. So 1, 1, 1. If we AND this, so 1 and 1 and 1 is simply 1. And after that, if we invert it, that is the output of the NAND gate is what? Simply 0. The output of NAND gate is what? Simply 0. So after that, if we take this case here, 1, 1, and here Q is feedback here. So what is the value of Q? Q is simply 0. So 0 in and something what? 0. So 0 complement is what? 1. So when it is 0 and it is 1, then what we will get? We will get the 0 and this is 1. So this part is what? This part is simply the SR latch. Okay, or latch. So in case of latch, if we go to the input 0 and 1, what we will get the value of Q and Q complement? It will be 1 and 0. So now first we assume the value of Q equal to 0 and Q complement equal to 1, but we will get the value of Q is 1 and Q complement is what? 0. So now Q and Q complement is inverted, that is first Q is equal to 0 and what we assume and 1. Now 0 is changed to 1 and 1 is changed to what? 0. So if we use that 1 and that 0 for further operation purpose or verification purpose in identifying the output or input operation for this JK flip-flop. So now what we have? Now we have Q complement is 0. So here we get 1, 0, and here we get in place of 0 what? 1. So here again this 0, 1 changes to what? 1, 0. So 1, 0 SR latch input give us output what? 0, 1. So we get what key? What? 0, 1. So 0, 1, 0 again what we will get? 1. Again what we will get? 0. Dot 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 dot. This condition is going. So this is very important concept. I request you guys to remember that. So this is very important concept of JK flip-flop. This is quite uncontrollable. So this condition is called the racing, not race around. This is the racing condition of a JK flip-flop. I request you to guys remember these things, and if you have any doubt or any problem in understanding, let's hear it out the lecture before 5 to 4 minutes. It will be quite clear to you, and if you have any query, ask me in the next session. Okay, so this is the condition of racing. Okay, so now we saw what will occur when both of the inputs are high. So this is the racing kind of things occurring here. So how will we denote the output Qn plus 1 here? So what will we see? Qn plus 1 first what? 0. After that it becomes what? 1. After that becomes what? 0. So it is quite complements of the present sets. This is 0. So what will be the present set? It has to be 1. And this is 1. What will be present? It has to be 0. So Qn plus 1 and Qn, the present state or the previous state, has complementary in nature. So what will we write here? We will write here Qn complement. So this Qn complement particularly called the toggle. So what is toggle? Using the toggle we will also build a different flip-flop that will denote as T flip-flop. We will learn it later. So this the Qn complement things only known as toggle. So what will be its and what will be its operation and what is this application, we will learn it in next session. So just remember those things, that this is racing and this is toggle. So till now, if you guys understood what I told you about the JK flip-flop and their operation and how will you overcome the condition when both of the inputs are in high stage. So now what we have? We have already the truth table of what? JK flip-flop. So if we have the truth table, so using that truth table, what will we write? We'll write the what? Characteristics table. So now we will write the characteristics table of a JK flip-flop. So in previous session we discussed about what is characteristics table, what is an extraction table, how characteristics table will be built using the truth table. So if you have any query regarding that, I request you guys please visit the previous session recorded version on paperwork. It will be quite clear. Let's make these things a little bit thinner. So this is the inputs. In MSB we will also has to keep the in MSB the previous state or present state, and it is the output Qn plus 1. Let's scroll it down a little bit. Okay. 0 0 0. Let's say input operation simply 0 0 1 1 0 0 1 1. After that what? 0 1 0 1 0 1 0 1. Now we must identify what are the values of Qn plus 1 using the truth table of a JK flip-flop. Is a characteristics table of a JK flip-flop. So how will we identify the value of Qn plus 1? So this is the things I discussed with you all in the previous session. So first case, J and K is 0 and 0. So this is 0 0. So 0 0 is what? 0 0 is simply Qn. So what is Qn? 0. 0 1 is what? 0. 1 0 is what? 1. 1 1 is what? 1 1 is what? In case of JK flip-flop, this is Qn complement. So I think you guys already remember that in case of SR flip-flop, what we write that here? Not valid. But such case will not occur in case of characteristics table of a JK flip-flop, because this is for SR flip-flop. So what will we write here? We write Qn complement. So what is the value of Qn complement for that particular input? Qn complement. Qn is 0. So what will be value of Qn complement? It will be 1. So after that what? 0 0 Qn 1 0 1 0 1 0 1 and 1 1. What at Qn complement? Qn is what here? 1. So this is 0. So this is the characteristics table of a what? JK flip-flop. So now what will we find? We will find the expression of Qn plus 1 in terms of Qn, J and K through 3 variable Carnot mapping method. So simply dot the 3 variable Carnot map here. JK must have 8 subcells. So what is 0 0 0 1 1 1 1 0? This is 0 1. So let's fill the boxes. 0 0 0 is 0. Fill it. 0 0 1 1 0 0 1 1. Okay. Simply pass 1 0 1 0 1 0 1 0. So this is the Carnot mapping. Okay. So let's pair these things. How will we pair? This is the first pair, clearly visible to our person. This is the second one. Okay. So what will be the expression for Qn plus 1? Let's pen it down. This is the first group and this is the second group. This will be from first group is what? In case of first group, Qn is 0. So this is Qn complement. J is 1 and K is changing. So K is excluded. So J. After that what? This one, in this case Qn, and here 0 to 1 and K. So what will we write here? We will write simply Qn that is for that part, and 0 to 1 j is changing, so we must exclude j, and k is 0. This is k component. So this is the expression for qn plus 1. Okay, so if in that characteristics table and expression finding, if you guys have any doubt regarding characteristics table, I request you to visit the previous session, that is lecture. This is lecture 80. The lecture 77 is a session about the characteristics table, excitation table, and truth table, and how we will write the characteristics table using truth table and excitation table using characteristics table. So these are the things quite correlated. So I request you to visit the previous session paperwork or recorded version. Then saw that session, it will be right clear. So now draw the excitation table of JK flip flop and find out the expressions for the inputs. So in case of excitation table, what? The outputs, present states, and next state will be the inputs, and J and K, it will be the output. 0 0 1 1 0 1 0 1. This is J, this is K. So first is Q, and Qn plus 1 is 0. So what will be the power? We must find out the value of J and K. So to find out what we need to use the characteristics table of JK flip flop. So 0 0. Find out on which cases the values of Q and Qn plus 1 0 0. So this is the first one. Let's use a different color for that first. Yeah, it's quite good. The brown one. Yeah. This is 0, this is 1. Sorry, 0. This is 0, this is 0. So this, anything more is there? 0, no. So in these two cases, Qn and Qn plus 1 both are 0. So what will be the value of input? J is 0 0, but K is changing. So if K is changing, we don't use the value of K. So K is not allowed, and J is what? 0 0. So the value of J is 0. After that, what? 0 1. So this is 0, this is 1. This is also 0, this is also 1. So this is the case of 0 1. In that case J is 1, so we must write J is 1, and K is changing. Okay, so K is not allowed. After that, what? 1 0. So let's find 1 0. This is 1, this is 0, this is 1, this is 0. So this is the two cases. In this case, 0 1, that is J is changing, but K is 1 1. J is changing, K is 1 1, this is 1. After that, 1 1. So this is 1, this is 1, this is 1, this is 1. So 1 1, J is changing, but K is what? 0. So let's bend it down. J is changing, K is 0. So this is the excitation table of JK flip flop. Now let's find out the expression of J and K separately. So this is a simply, this color is not white. Okay, so let's use that red color. Yeah, this is good. Is 0 1 0 1. So what we will get? 0 0 is 0. In case of J, this is for J. So through that K mapping, we will find out the expression of J. So 0. After that, what? 0. After that, 1 0 0 1 1 1 0 is what? Not allowed. 1 1 is what? Also not allowed. So what we will do? We discuss about that in previous session. 1 not allowed. This is the only solitary pairing. In this case, what? Qn is changing, but Qn plus 1 is Qn plus 1. It is 1, so J is Qn plus 1. This is the expression of J. Now we must find out the expression of K. So for finding the expression of K, here the K mapping. What will be the value of that? Not allowed, 1 0. Right? So this is the fair. So what will be the 0 1 0 1? What will be the value of K? K is equal to what? So in this case, Qn is changing by Qn plus 1 is or 0. So K is equal to Qn plus 1. So this is the excitation table and the expression of inputs, that is J and K, in terms of the output Qn as well as Qn plus 1. Okay. So till now I discussed everything about what is JK flip-flop. Okay. And why will we need JK flip-flops? Still we have the SR flip-flop as well as D flip-flop. And what are the conditions that we will overcome through JK flip-flop that we didn't uh, did with the SR flip-flop, and also the truth table, racing condition, what is toggle state in case of Qn plus 1 next state. Also the excitation table is characteristics table. So JK flip-flop. So I request you guys, so go through that session. So in next session we will discuss more about more applications, and also master slave, what is master slave, JK flip-flop, why we need that. Okay, also race around condition is what, how will we overcome that, drawbacks. These are the things we will discuss in next session. Also the T flip-flop at historical conditions, I will discuss this. And if you guys interested, then I will discuss you and show you and one example about how we will convert one flip-flop conversion. The excitation, sorry, the characteristic table excitation table I write recently. The characteristic table is most useful for converting one flip-flop to another one. So these are the things we will discuss further in next session. So till now, if everything clear to you, so thank you everyone for your time. And if any queries are there, ask me the next session. Also my numbers, I think you guys already had my number. So if you don't, you will find it in our YouTube channel everywhere, and you may Google it and also find my number. It will be visible in our front if you search it through my name. Okay, yeah, so that's it. So good night everyone, have a nice day.